Today we're going to be taking on the periodic phase of beta oxidation. We have succeeded in transporting the fatty acid into the cytoplasm of the cell. So the activation of fatty acid is very necessary for the process of beta oxidation to occur, for us to be able to transport it into the mitochondrial matrix and for it to undergo beta oxidation. So it's necessary for us to activate it, and to activate it we are just adding coenzyme A to the fatty acid to change it to fatty acyl CoA. So now this is the fatty acid in the cytoplasm. This activation occurs in the cytoplasm close to the mitochondrial the outer mitochondrial membrane, close to the outer mitochondrial membrane in the cytoplasm. So now to activate this, we need this enzyme called thiokinase or acyl CoA synthetase. This is called acyl CoA synthetase. So what this enzyme does is that the enzyme is catalyzing this activation process in two steps. First, to combine the fatty acid with AMP here. Then the next step, to combine it with the coenzyme A. So let me show you how this actually happens. So before I go, before I go to the next slide, let's look at this enzyme here too. It's inorganic pyrophosphatase. It acts on AMP. It acts on pyrophosphate, converting it to inorganic, was 2 molecules of inorganic phosphate, 2 molecules of inorganic phosphate. So this process of converting this pyrophosphate to 2 molecules of inorganic phosphate actually drives this reaction forward. So let me show you what I'm talking about. Sorry, clean this. So as you can see here, we have ATP here. This is ATP. This is ATP. This is adenosine, as you can see here, and these are the 3-phosphate group. This 3-phosphate group. So as you can see here, this adenosine. Adenosine is a nucleoside. That means adenine plus what? Adenine plus a ribose sugar. So now you have adenosine and a 3-phosphate group. So you have 3 inorganic phosphate group. So you now have this structure as ATP. So since this is ATP, you see, if you look at the first slide, you see that there's an oxygen that is negatively charged. So you remember this enzyme is the one catalyzing this step now. So this oxygen will attack this ATP here. So if it attacks this bond. The oxygen attack this bond. So when it attacks this bond, these ones pull out and you have pyrophosphate. You see that you have your pyrophosphate here. So looking at this now, how many oxygen is with this phosphate left here? You have 1, 2, and 3. So this oxygen, the attack, will stay here. So look at it. This is what you have. AMP. This is the AMP. You can see that this is the AMP. So this AMP now, remember that the oxygen coming here now. Remember, oxygen needs 2 electrons. They are in need of 2 electrons because they have 2 outside, so they need 2 to bind to. So now this oxygen is binding to this phosphate via this bond. You can see the bond here. Then now there's one more because you can see minus here. So since there's need, and if you look at this here, if you look at this fatty acid structure here now, after removing this high oxygen, there is need for 1 electron to balance this for this whole structure here. Because you can see the last carbon here, it has a bond here 1, and it forms double bond with this oxygen here, which is 2 double bond, remaining how many now? 1, because carbons need 4 they have 4 electrons for binding, for bond formation. So now, since it's 3 that this carbon is having, so it's in need of 1. So it will bind with this. To bind with this. You can see it here. This is the electron here. You can see. To bind with this. This B represents the rest of this compound here. The meaning of this. Let me clean this. It represents the B. The B represents this. And you know this is already gone. So you can see it here. So the phosphate will bind with this and form what? And form this fatty acyl adenylate. Form fatty acyl adenylate. So this inorganic pyrophosphate here. Let's look at the action of inorganic pyrophosphate here now. We are done with the action of this thiokinase. We are not. We are done with the action. The first part of its action. First part of its action. We are done with it. So now this inorganic pyrophosphate. Let's look at how it acts. This inorganic pyrophosphate. What it does is. This is the pyrophosphate. The pyrophosphate is here. This is the pyrophosphate. This is the pyrophosphate. So now it does the same thing. It will bring in oxygen, introduce in oxygen, put it at this bond. Let me show you the bond. Put it at this bond here. Then what happens? This one leaves, and the oxygen stays. We have 1, 2. You have 1, 2, 3, then 4. The oxygen. This one too has 1, 1. This one too has 1, 2, 3, 4. So you see, you now produce how many molecules of inorganic phosphate? 2 molecules of inorganic phosphate. Simple as that. So that's how it works. So now I'll go to the next step. The next step. This step is still catalyzed by thiokinase, the acyl-CoA synthetase. This is the second step where it combines with the coenzyme by and remove this adenosine monophosphate, the AMP. So now the enzyme here, the enzyme is still the thiokinase. So what it does is this coenzyme A. This coenzyme A is in cytoplasm, cytoplasmic coenzyme A. So when it adds the coenzyme A, you can see here it's having negative charge, meaning looking for 1. So this hydrogen is removed from it. We can add it to this AMP because look at the structure of AMP. This structure of AMP, this is how AMP structure is. So you don't think of adding it to it because as physiological pH, bicarbonate exists as this negatively charged. It's not complete like this. So you can see that. So same with these ones. So now we're not going to add it, so we'll take it out. But there are some cases that I would like to maybe for explanation's sake I'll add the H. So but here there's nothing like that. So now we'll add the coenzyme A to the fatty acyl and remove the adenylate, which is the AMP. So when we add it, you get this. You can see that the only change is AMP was removed. You can see the only change was that AMP was removed and this was added. So you now have a fatty acyl CoA. So we'll be transporting this fatty acyl CoA into the mitochondrial matrix. So the compound that will be helping us to do that is called carnitine, L-carnitine. So in the next video, we'll transport this fatty acyl CoA into the mitochondrial matrix. So thanks for watching. Please subscribe and make sure you press on the notification bell. Thank you very much. Thanks for watching.